In Shplait, we mostly bind variable names using def or fun, and we can use these forms inside of a block for local definition. For example, here I've defined x to be 10 within this block, so of course the answer is going to be 11. I can also use fun inside of a block like this. In this case, I've defined a function that takes an x, and when we call it with 1, then, well, we call f with 1, which means that we call f with 1, and so on. This function turns out to be an infinite loop, but I'm going to call that good for our current purposes because it's showing that we can, on the right-hand side of a function definition, refer back to the function that we are defining. We have a kind of recursive binding. And of course, that is useful for writing interp or factorial or other functions. So we're going to view infinite loops as a kind of good capability for recursive binding. Now def can also, when you use def, the right-hand side can also refer to the name that you're defining. However, in this case, we don't get an infinite loop or anything like that. We get use before initialization. That's because with def, you need to evaluate or interpret the right-hand side before you can define the name x and carry on to the body. And by the time that we get to this x, even though it can see it, there is no value yet. So that's before x is initialized. It doesn't help if we make a list around x because, again, we need to create the list, and to create the list we need the value of x. We'll still get a use before initialization here. On the other hand, if the right-hand side of this definition is a function that takes an argument x here, so this is the lambda-like expression form of a function, then we don't have to interpret the body right away, and so we don't have to look at f right away, and so this one will work again. We will get an infinite loop in this case. So I'm using def to bind f to a function. That function refers back to f, but I don't actually need to look at that self-reference until after I call the function, at which point f is bound. Okay, so this again illustrates that we can define recursive functions just using def. The Letrec form that we use in Mo also works in Shplait. It's just a shorthand for a block that is a def of one thing like this. So it's the same as we have before. We're letting f be this function that calls itself, and then we call it with 1, so we get that good infinite loop. Does it work if we put that function inside of a list like this? Yes, it does. So in this case, we'll get an infinite loop because what happens is we do have to create the list. Inside that list, we get a value that's a function. We don't have to look at the function body right away. So we get a list containing a function, and then we take the first of that list, which is a function. We call it with 1, which takes the first of that list, calls it with 1, and so on and so on. So the point here is that Letrec is generalized in Shplait to not require a function on the right. It can be something else that could make sense, like a list of functions.